Most of the U.S. offshore energy production is oil and natural gas. The first offshore oil well was drilled in 1897 at the end of a wharf 300 feet off the coast of Summerland, California. And that is wharf, spelled WHARF. Early offshore drilling occurred in water less than 300 feet deep. Oil and natural gas drilling rigs now operate in water as deep as 2 miles. Offshore oil and natural gas production is much more expensive than onshore, land-based production. So here we have 2 more pictures. First one is a map of the continental United States with Alaska just above Washington State, and it's titled U.S. Oil and Natural Gas Fields Sources Natural Energy Education Development Project, and it's public domain. The next picture, however, is titled Offshore Oil Rig Source Stock Photography, copyrighted. Okay, so moving on to the reading. Offshore oil and natural gas wells are drilled from platforms that hold the drilling equipment, storage areas, and housing for work crews. Some drilling platforms stand on stilt-like legs that are embedded in the ocean floor. Floating platforms are used for drilling in deeper waters, including water depths of 10,000 feet or greater. These self-propelled vessels are attached to the ocean floor by large cables and anchors. After wells have been drilled from these platforms, production equipment is lowered to the ocean floor. Offshore oil and natural gas producers are required to take precautions to prevent pollution, spills, and significant changes to the ocean environment. Offshore rigs are designed to withstand hurricanes. When offshore oil and natural gas wells are no longer productive enough to be economical, they are sealed and abandoned according to applicable regulations. Nearly all offshore oil and natural gas leasing and development activity occurs in the central and western Gulf of America, where thousands of platforms operate in waters up to 6,000 feet deep. A few platforms operate in depths of 10,000 feet or more. In 2022, oil and natural gas production in the federal offshore Gulf of America accounted for about 15% of total U.S. crude oil production and about 2% of total U.S. dry natural gas production. Other energy sources are under development offshore. Other types of energy technologies are operating or under development offshore in the United States, including wind energy, wave energy, tidal energy, ocean thermal energy conversion, and methane gas hydrates. This page was last updated April 16, 2024. Next section, use of oil. Basics. Crude oil and other liquids produced from fossil fuels are refined into petroleum products that people use for many different purposes. Biofuels are also used as petroleum products, mostly in mixtures with gasoline and diesel fuel. Petroleum has historically been the most consumed energy source in terms of total annual U.S. energy consumption. We use petroleum products to propel vehicles, to heat buildings, and to produce electricity. In the industrial sector, the petrochemical industry uses petroleum as a raw material, a stock feed, to make products such as plastic, polyurethane, solvents, and hundreds of other intermediate and end-user goods. In 2022, U.S. total petroleum consumption averaged about 20.28 million barrels per day, which included about 1.17 million barrels per day of biofuels. 1.002 barrels per day of fuel ethanol and 0.164 barrels per day of biodiesel, renewable diesel, and other biofuels combined. Footnote 1. U.S. total petroleum consumption was about 2% higher in 2022 than in 2021, and about 12% higher than in 2020, largely because the U.S. economy was returning to pre-COVID-19 pandemic activity levels. Consumption of nearly all petroleum products in 2020 was higher than in 2021. So I'm going to pause the reading and read footnote 1. The U.S. Energy Information Administration uses product supplied to represent petroleum consumption. Fuel ethanol consumption is accounted for as refinery and blender inputs to produce finished motor gasoline. Resuming the reading. Did you know? The transportation sector amounts for the largest share of U.S. petroleum consumption. The percentage share of total U.S. petroleum consumption by major end-use sectors in 2022 was 66.6% in transportation, 27.5% industrial, 2.8% residential, 2.5% commercial, 0.6% electric power. Data source: U.S. Energy Information Administration Monthly Energy Review, July 2023. Preliminary data. U.S. petroleum products consumption by source and sector. 2022. Million barrels per day. So, first, on the left-hand side, you have the source, and it is motor gasoline, distillate fuel oil, hydrocarbon gas liquids, jet fuel and aviation gasoline, and other category. The total is 20.3 million barrels per day. Motor gasoline is the biggest source at 8.8 million barrels per day, which accounts for 43%. Distillate, actually, before I go on, 96% of that goes to transportation. On the right-hand side of this graphic, you've got the section, and you have three sections, or three parts. Transportation, which accounts for 67%, industrial, 27%, and then residential, commercial, and electric power, which is 6%. So 96% goes to, looks like, transportation, 2% goes to industrial, and 2% goes to residential, commercial, and electric power. So next we have distillate fuel oil, 4.0 million barrels per day, 20%. 75% goes to transportation. 14% goes to industrial, and 11% goes to residential, commercial, and electric. Next, hydrocarbon gas liquids, 3.6%. Sources: U.S. Energy Information Administration, EIA, Monthly Energy Review. April 2023, tables 3.5, 3.7a, 3.7b, and 3.7c. Note: data include biofuels mixed with petroleum products. Some of components may not equal total amount to independent rounding. See quote and extended chart notes, end quote, on next page. So A includes asphalt and road oil, aviation, gasoline, blending components, lubricants, kerosene, petrochemical feedstocks, petroleum coke, residual fuel oil, still gas, refinery gas, special naphthas, waxes, unfinished oils, and miscellaneous products. Also includes biofuels, excluding fuel ethanol products supplied. B. Industrial, commercial, and electric power sectors include primary energy consumption by combined heat and power, CHP, and electricity-only plants in the sector. What petroleum products do people consume most? Gasoline is the most consumed petroleum product in the United States. In 2022, consumption of finished motor gasoline averaged about 8.78 million barrels per day, 369 million gallons per day, which was about 43% of total U.S. petroleum consumption. Finished motor gasoline includes fuel ethanol. Distillate fuel oil is the second most consumed petroleum product in the United States. Distillate fuel oil includes diesel fuel and heating oil. Diesel fuel is used in diesel engines, which are often in heavy construction equipment, trucks, buses, tractors, boats, trains, some automobiles, and electricity generators. Heating oil, also called fuel oil, is used for heating homes and building in boilers and furnaces, for industrial heating, and for producing electricity in power plants. In 2022, total distillate fuel oil consumption averaged about 3.96 million barrels per day, 166 million gallons per day, which was 20% of total U.S. petroleum consumption. Hydrocarbon gas liquids, HGLs, the third most used category of petroleum in the United States, include propane, ethane, butane, and other HGLs that are produced at natural gas processing plants and oil refineries. HGLs have many uses. Total consumption of HGLs in 2022 averaged above 3.59 million barrels per day, accounting for about 18% of total petroleum consumption. Jet fuel is the fourth most used petroleum product in the United States. Jet fuel consumption averaged about 1.56 million barrels per day, 65 million gallons per day in 2022, accounting for about 8% of total petroleum consumption. Major types and amounts of U.S. petroleum products consumed 2022. So here's a table. On the left-hand side is the product. On the right-hand side, it's annual consumption, measured in million barrels per day. Finished motor gasoline, 8.777 million barrels per day. Distillate fuel oil, diesel fuel and heating oil, 3.962 million barrels. Hydrocarbon gas liquids, HGLs, 3.588 million barrels per day. Kerosene type jet fuel, 1.558 million barrels per day. Steel gas, 0.661 million barrels per day. Asphalt and road oil, 0.373 million barrels per day. Residual fuel oil, 0.343 million barrels per day. Petroleum coke, 0.255 million barrels per day. Petrochemical feedstocks, 0.237 million barrels per day. Biofuels, 0.164 million barrels per day. Lubricants, 0.112 million barrels per day. Unfinished oils, 0.094 million barrels per day. Miscellaneous other products, 0.087 million barrels per day. Or that would be about 87,000 barrels per day. Special naphthas, 0.046 million barrels per day. Aviation gasoline, 0.012 million barrels per day. Waxes, 0.006 million barrels per day, or about 6,000 barrels per day. Kerosene, 0.004 million barrels per day. And total petroleum products, 20.279 million barrels per day. Data source, U.S. Energy Information Administration, petroleum and other liquids products supply as of June 2023. Note, some of individual products may not equal total because of independent rounding. Finished motor gasoline includes fuel ethanol, biofuels. Biofuels include biodiesel, renewable diesel, and other biofuels. Miscellaneous other products includes all finished petroleum products not classified elsewhere, including petroleum, lube refining byproducts, aromatic extracts and tars, absorption oils, ramjet fuel, petroleum, rocket fuels, synthetic natural gas feedstocks, and specialty oils. How much petroleum does the world consume? In 2021, total world petroleum consumption was about 97.26 million barrels per day. The five top petroleum consuming countries and their percentage shares of total world petroleum consumption in 2021 were United States 20.4%, China 15.7%, India 4.8%, Russia 3.8%, Japan 3.5%. Data source: U.S. Energy Information Administration, International Energy Statistics, as of August 21st, 2023. What is the outlook for U.S. petroleum consumption? In the Annual Energy Outlook 2023 reference case, the U.S. Energy Information Administration projects U.S. total consumption of petroleum and other liquids in 2050 to be nearly equal to the projection for 2023. Petroleum and other liquid fuels will decline from about 37% of total U.S. energy consumption in 2023 to about 34% of total annual U.S. energy consumption in 2050. Also in the reference case, liquid fuels continue as the main energy source for the transportation sector. But transportation sector liquid fuels consumption on an energy content basis is projected to be about 10% lower in 2050 than in 2023. This page was last updated August 22nd, 2023, with data available from source reports as indicated. Data for 2022 are preliminary. Next section, oil prices and outlook. Basics. Oil prices and outlook. Crude oil prices are driven by global supply and demand. Economic growth is one of the biggest factors affecting petroleum product, and therefore crude oil demand. Growing economies mean a higher demand for energy. In general, especially for transporting goods from producers to consumers. The world's transportation sector depends almost totally on petroleum products such as gasoline and diesel fuel. Many countries also rely primarily on petroleum fuels for heating, cooking, or generating electricity. Petroleum products made from crude oil and other hydrocarbon liquids account for about 1/3 of total world energy consumption. OPEC can influence world oil supplies and prices. The Organization of Petroleum Exporting Countries, OPEC, can significantly influence oil prices by setting production targets for its members. OPEC includes countries with some of the world's largest oil reserves. At the beginning of 2021, OPEC members controlled about 72% of total world proved crude oil reserves, plus lease condensate, and they accounted for 37% of total world crude oil production in 2021. OPEC attempts to manage its member countries' oil production by setting crude oil production targets or quotas for its members. OPEC compliance with OPEC member compliance with OPEC quotas is mixed because production decisions are ultimately in the hands of the individual members. So now we have two graphs on the left-hand side. It's titled Average Monthly U.S. Refiner Acquisition Cost of Crude Oil, 1975 to 2022. It's a line graph. For the x-axis, you have dollars per barrel. From the bottom, you have 0. The top, you have 130. So, and then the y-axis, you have years 1975 all the way to the edge, which is 2022. Beginning of 1975, January, it was $9.48 a barrel. It increased to $37.28 a barrel in February 1981. So between those years, there was it's been increasing. Gradual for the first few years up until around 1979, and then it got sharper from February 1979 till about February 1981, and then there was a decline up until gradual decline until April 1985, September 1985, then around 1986, January, and then between March and February 1986, there was a sharp decrease. January 1986, it was $25.63 a barrel. But then we go to March, drops to $14.80 a barrel. Then it drops a bit more in August 1986, $11.93 a barrel. And as the months and years go by, there's gradual increase, drops, increase in price. Then we go to October 1990. There's another high point where it's $33.14 a barrel. But then shortly after, around November, December 1990, drops to $26.09 a barrel. February 1991, $19.03 a barrel. August 1991, $18.92 a barrel. So there's just fluctuation. Then there's another decrease. November 1993, $14.51 a barrel. And then a low point in March 1994, $13.16 a barrel. Then there's gradual increase over the years. April 1995, $18.43 a barrel. Some increase, some decrease. September 1996, $21.09 96 cents a barrel. December 1996, $23.30 a barrel. And between then and February 1987, there's a decrease. June 1997, $17.80 a barrel. July 1998, $11.90 a barrel. So you just keep going throughout the years. Between 1998 and 2000, it's gradual increase, then drops back down around, starts to drop around November of 2000, back down to $16.52 in December 2001. So I'm going to skip over. As the years go by, it goes past $30 a barrel. September 2004, $41.35 a barrel. August 2005, $59.30 a barrel. July 2006, $68.86 a barrel. October 2007, $79.87 a barrel. July 2008, $129.03 a barrel. And sharp, massively sharp decrease in January 2009, where we are back at the $30 range, $37.45 a barrel. Over time, it launches back into the $100, more than $100 a barrel range. May 2011, $107.84 a barrel. Then, around the year 2014, June, $102.51 a barrel. But then some months later, we're seeing a sharp decline. March 2015, $47.99 a barrel. February 2016, $28.53 a barrel. June 2018, $68.35 a barrel. April 2020, $19.32 a barrel. June 2022, $114.44. And then December 2022, $76.56 a barrel. Data source, U.S. Energy Information Administration, Petroleum Marketing, monthly, February 2023. Note, costs are nominal value, not adjusted for charges in the value of the U.S. dollar. And are the composite acquisition cost of crude oil for U.S. refiners. Next, we have another graph. I won't go into detail like with the line graph, but it says on top, world oil market, spare capacity, and call on OPEC. On the x-axis, you have production capacity, non-OPEC, and OPEC. And then oil supply. Y-axis, you've got theoretical maximum world oil production capacity. Call on OPEC includes stock changes. This theoretical example assumes constant production capacity. Actual production capacity changes over time. Source is U.S. Energy Information Administration. Back to the reading. In general, the main factors determining OPEC's ability to influence oil prices include the extent to which OPEC members comply with production quotas, the ability or willingness of consumers to reduce petroleum consumption in response to higher product prices. The competitiveness of non-OPEC producers when oil prices change. The efficiency of OPEC producers to supply oil compared with non-OPEC producers. The difference between oil market demand and supply from non-OPEC sources is often referred to as the call on OPEC, because OPEC members maintain the world's entire spare crude oil production capacity. Saudi Arabia, the largest OPEC oil producer and one of the world's largest oil exporters, historically has had the largest share of the world's spare oil production capacity. Developing and maintaining idle spare production capacity is generally not cost-effective for international oil companies, OIC, because the OIC business model maximizes revenue by producing oil as long as the price of selling the oil is higher than the cost of supplying an additional barrel of oil to the market. OPEC's spare capacity is an indicator of the world oil market's ability to respond to real and potential disruptions in world oil supplies. Did you know the U.S. Energy Information Administration, EIA, defines spare capacity as the volume of oil production that can be brought online within 30 days and sustained for at least 90 days. Essentially, spare capacity is the difference between a country's current oil production and its maximum oil production capacity. If a supply disruption occurs, oil producers can use spare capacity to moderate increases in world oil prices by boosting production to offset reduced oil supplies. World crude oil prices and supply disruptions are the result of several factors. Geopolitical events and severe weather that disrupt the flow of crude oil and petroleum products to market can affect crude oil and petroleum product prices. These events may create uncertainty about future supply or demand, which can lead to higher price volatility. Oil price volatility is tied to low responsiveness or inelasticity of supply and demand to price changes in the short term. Crude oil production capacity and the equipment that uses petroleum products as its main source of energy are relatively fixed in the near term. It takes time to develop new supply. Or to vary production. And when prices rise, switching to other fuels or increasing equipment fuel efficiency in the near term is challenging for consumers to do. These conditions may require a large price change to rebalance physical supply and demand. Most of the crude oil reserves in the world are located in regions that have been prone to political upheaval, or in regions that have had oil production disruptions because of political events. Several major oil price shocks have occurred at the same time that political events caused supply disruptions, most notably the Arab oil embargo in 1973 to 1974, the Iranian Revolution, the Iran-Iraq War in the 1980s, Persian Gulf War in 1990 to 1991. In recent years, conflicts and political events in the Middle East, the Persian Gulf, Libya, and Venezuela have contributed to world oil supply disruptions and have resulted in higher oil prices. Given the history of oil supply disruptions caused by political events, market participants constantly assess the possibility of future disruptions. In addition to the size and duration of a potential disruption, market participants also consider the availability of crude oil stocks and if other producers can offset a potential supply loss. When spare capacity and inventories are low, a potential supply disruption may have a greater impact on prices than might be expected if we only examine current demand and supply. Weather also plays a significant role in crude oil supply. Hurricanes in the Gulf of America can affect oil production and refinery operations in the Gulf region. As a result, U.S. petroleum prices may increase sharply as supplies from the Gulf to other regions drop. Severe cold weather can also strain product markets as producers attempt to supply enough product, such as heating oil, to consumers in a short amount of time. This seasonal demand can also result in higher prices. Other events, such as refinery outages or pipeline problems, can also restrict the flow of crude oil and petroleum products to market. These events can lead to a temporary supply disruption that could increase prices. The effect of these factors has on crude oil prices tends to be relatively short-lived. Once the supply disruption subsides, the oil and product supply chains adjust, and prices usually return to their previous levels. Buyers and sellers are participating in global auction. Crude oil and petroleum product prices are the result of thousands of transactions taking place simultaneously around the world at all points in the supply chain, from the crude oil producer to the individual consumer. Oil markets are essentially a global auction. The highest bidder will win the available supply. Like at any auction, bidders don't want to pay more than they have to. When markets are tight, when demand is high, or when available supply is low, the bidder must be willing to pay a higher price. When markets are loose, demand is low, or available supply is high, a bidder may choose not to outbid competitors, waiting instead for lower priced supplies. Different types of oil market transactions are available. Contract arrangements in the oil market cover most crude oil that changes hands. Crude oil is traded in the futures markets. A futures contract is a standard contract to buy or sell a specific commodity of standardized quality, at a certain date in the future. If oil producers want to sell oil in the future, they can lock in their desired price by selling a futures contract today. Alternatively, if consumers need to buy crude oil in the future, they can guarantee the price they will pay at a future date by buying a futures contract. In addition to oil producers and consumers, futures contracts are also bought and sold by market participants or speculators who do not produce or consume crude oil. These types of traders buy and sell futures contracts in anticipation of price changes, hoping to make a profit from those changes. Crude oil is also sold in spot transactions, on-the-spot purchases of a single shipment for prompt delivery at the current marketplace. Changes in prices send signals to the market. Prices in spot markets send a clear signal about the balance of supply and demand. Rising prices indicate that additional supply is needed, and falling prices indicate there is too much supply for current demand. Futures markets also provide information about the physical supply and demand balance, as well as the market's expectations. The outlook for crude oil prices is uncertain. The significant changes in world oil prices in the past demonstrate how all of these factors can influence oil prices, and they demonstrate the difficulty in projecting oil prices. EIA projects crude oil prices in the short-term energy outlook, Table 2, energy prices, and annual energy outlook, Table 12, petroleum and other liquids prices, reference case and side cases. Last updated August 16, 2023. Now moving on to the last section. Oil and the environment. Basics. How does oil affect the environment? Crude oil is used to make the petroleum products we use to fuel airplanes, cars, and trucks, heat homes, make products such as medicines and plastics. Although petroleum products make life easier, findings producing and moving crude oil may have negative effects on the environment. Technological advances in oil exploration, production, and transportation, and enforcing safety and environmental laws and regulations help to avoid and reduce these effects. How does technology help reduce the impact of drilling for and producing oil? Exploring and drilling for oil may disturb land and marine ecosystems. Seismic techniques used to explore for oil under the ocean floor may harm fish and marine mammals. Drilling an oil well on land often requires clearing vegetation. However, technologies that significantly increase the efficiency of exploring and drilling activities also reduce their effect on the environment. Satellites, global positioning systems, remote sensing devices, and 3D and 4D seismic technologies make it possible to discover oil reservoirs with fewer exploratory wells. Mobile and smaller slim hole drilling rigs reduce the size of the area that drilling activities affect. Using horizontal and directional drilling makes it possible for a single well to produce oil from a much larger area which reduces the number of wells necessary to develop an oil resource. What is hydraulic fracturing? Hydraulic fracturing, or fracking, is used to produce oil from shale and other tight geological formations, underground rock layers. This technique has helped the United States to significantly increase oil production and reduce oil imports. Fracking can affect the environment. Fracturing rock requires large amounts of water, and it uses potentially hazardous chemicals to release the oil from the rock strata. In some areas of the country, significant water use for oil production may affect the availability of water for other uses and could affect aquatic habitats. Faulty well construction or improper handling may result in leaks and spills of fracturing fluids. Fracking also produces large amounts of wastewater that contain harmful compounds. Because treating the wastewater can be difficult and expensive, in some places it is injected deeply underground. However, this disposal method may cause earthquakes that are large enough to damage buildings. How do we prevent oil spills? Most oil spills are the result of accidents at oil wells or on the pipelines, ships, trains, and trucks that move oil from wells to refineries. Oil spills contaminate soil and water and may cause devastating explosions and fires. The federal government and oil industry work together to reduce the potential for accidents and spills, and to clean up spills when they occur. After the Exxon Valdez oil spill in Prince William Sound, Alaska in 1989, the U.S. Congress passed the Oil Pollution Act of 1990. This law requires all new oil tankers built for transport between U.S. ports to have a full double hull. In 1992, the International Maritime Organization also established double hull standards for new oil tankers in the International Convention for the Prevention of Pollution from Ships, MARPOL, MARPOL. The amount of oil spilled from ships dropped significantly during the 1990s, partly because of these double hull standards. The Deep Horizon drilling rig explosion and oil spill in the Gulf of America in 2010 prompted the U.S. government and the oil industry to review drilling technologies, procedures, and regulations to help avoid similar accidents in the future. The U.S. government also replaced the Minerals Management Service, MMS, which administered offshore and natural gas leases, with the Bureau of Ocean Energy Management, BOEM, and the Bureau of Safety and Environmental Enforcement, BSEE, to provide more effective oversight and enforcement of environmental regulations for offshore energy development. And here is an image, and it's titled Fish Swimming Through Rigs to Reefs Project. The source is courtesy of the Mississippi Department of Marine Resources. In response to several major accidents involving trains carrying crude oil, the U.S. Department of Transportation and the Federal Railroad Administration set new standards for railroad tank cars, braking controls, and speed restrictions to reduce the potential for railroad accidents and oil spills. How do old well sites become artificial reefs? When oil and natural gas wells become uneconomic, they must be properly plugged and abandoned under state and federal regulations, and the area around the well must be restored. These procedures properly seal off subsurface rock formations and restore well sites to their original condition. Wells that are not properly plugged and abandoned are potentially hazardous and leaking fluids and gases. Leaking fluids and gases could interfere with future surface development. The U.S. Environmental Protection Agency is working to address this issue. Some old offshore oil rigs are tipped over and left on the seafloor in a rigs to reef program. Within a year after a rig is toppled, barnacles, coral, sponges, clams, and other sea creatures cover the rig. These artificial reefs attract fish and other marine life, and they increase fish populations and recreational fishing and diving opportunities. So that is the end of this section. And the series, we can call it, on oil and petroleum products explained.